Hey everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this complex equation to solve. We have z plus 2 plus j over 2z minus 1 all to the power 4 equal to 1, whereby j is an imaginary number equal to a square root of negative 1. All right, so what are you thinking on applying here? Now calm down, relax. Let's solve together and have fun. Okay. So the approach that we're going to be applying here, first of all, we have this expression to the power 4. Many would have applied a fourth square both sides to eliminate here, to isolate this expression, and they will be having here 1. That will be wrong, and you will be losing some solutions. So what you can do, or what we can do in this particular case, we can send this 1 that is on the right side to the left side. So this will be like this. Okay. Now, if we check, we know that a squared minus b squared is equal to a plus b times a minus b, the difference of 2 squared. But we don't have the difference of 2 squared here. But we can say where there is 4, it's the same as 2 squared all squared, and 1 is also 1 squared. Now this becomes my a and this becomes my b, so I can apply this rule. So I'm gonna have z plus 2 plus j over 2z minus 1 squared minus 1 times z plus 2 plus j over 2z minus 1 squared plus 1 equal to 0 according to this rule. Now, those two expressions are multiplying. The product of two expressions is equal to 0 if at least one of them is 0. So what we can do? We can start by solving first this problem. So this one then, we can say z plus 2 plus j over 2z minus 1 squared minus 1 being equal to 0, or the second one being equal to 0. Second one being equal to 0. Now this expression, again, we can apply this principle because there is some expression squared minus 1. We know that 1 is also 1 squared. So now we can apply the difference of 2 squared. So this implies, for this case, I'm going to call star 1, and this one I'm going to call star 2. So let's solve star 1. So in star 1, we're going to have z plus 2 plus j over 2z minus 1 times z plus 2 plus j over 2z minus 1 plus 1 equal to 0. Let's just leave this expression. Let's just solve this one. So these imply that we have the first one equal to 0, or the second one 2z minus 1 being equal to 0. So we reduce the equation into these two equations, except that part that we will be solving. So what we can do now? We can now solve this equation and then solve this equation. All right, let's solve together. So we check that we have negative 1 here and we have plus 1. We can send this 1 here, this side. So here is negative, will come here positive, and here is positive, will come this side, negative 1. So it's not a problem to do that. So now let's cross multiply the first equation, which I'm going to call equation line A. Crossing multiply, I'm going to have z plus 2 plus j equal to 2z minus 1. So I send these expressions, so I'm going to have z minus 2z equal to minus 1 minus j minus 2. So minus z will be equal to minus 3 minus j, multiplying both expression by negative 1, so z will be equal to 3 plus j. So that's the first value of z. So let's go for equation B, which is this one. Crossing multiply, we're going to have z plus 2 plus j is going to be equal to 2z. In this particular case, there is negative, so minus 2z, and then plus 1. Sending z, we have z plus 2z equal to 1 minus 2 minus j. Now we have here 3z minus 1 minus j. So z will be equal to minus 1 over 3 minus 1 over 3j. So that's the second value of z. All right. Now let's solve star 2, which is this equation that we left. So in this particular equation, we have z plus 2 plus j over 2z minus 1 squared plus 1 equal to 0. Now the question is, the same way we transformed this expression to be difference of 2 squared, can we apply here? Yes, of course we can. We know that j is square root of negative 1, so that means we can say this is minus j squared, because j squared is minus 1, with this minus we'll go back to plus 1. Now it's the difference of 2 squared. So we can now say it's going to be z plus 2 plus j over 2z minus 1 minus j times z plus 2 plus j over 2z minus 1 plus j equal to 0. So the product of two expressions is only equal to 0 if at least one of them is 0. So let's solve this equation. Now I'm going to call C because we had A and B. So solving this equation, we can send already this minus j to the right side, will be j. So we're going to have z plus 2 plus j over 2z minus 1 being equal to j. Crossing multiply, z plus 2 plus j will be equal to 2j minus j. Sending the side, z will be 1 minus 2j equal to minus j minus 2, because this is positive, goes that side, and negative. So z will be equal, we can factorize minus 2, we will have 1 plus j over 1 minus 2j. So rationalizing it, we have to multiply by the conjugate of the denominator. So to multiply by the conjugate of the denominator, we're going to multiply by 1 plus 2j over 1 plus 2j. All right, so z will be equal to minus 2, 1 plus 2j plus j, j times j squared, so minus 2 over, here will be 1 squared plus 2 squared. Because multiplying a complex number by its conjugate is just the real part squared plus the imaginary part squared. So z will be equal to, here we're going to have minus 1. So minus 1 here times minus 2 will be 2. And then here will be 3j times minus 2, so minus 6j over 5. So z will be equal to 2 over 5 minus 6 over 5j. All right. So this is the third value of z. Okay. So let's now solve d. So d is working with this expression. So we have z plus 2 plus j multiplying minus j. So will be minus 2 zj and then plus j. Okay, so we send this side, we have z 1 plus 2j equal, those two are cancelled out, goes negative there, z will be minus 2 over 1 plus 2j. Multiplying by 1 minus 2j, we have z equal to minus 2 plus 4j over 5. Z will be minus 2 over 5 plus 4 over 5j. So that's the fourth value of z. And since the highest degree of our equation is 4, so it makes sense having 4 roots for z. All right. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.